Chapter 9.3 Notes, Double Angle, Half Angle, and Reduction Formulas. This is page 4. So exercise 6 at the top here, prove an identity using power reducing formulas. I will be honest, first time I did this, I started with the right-hand side because that looked more complicated. I figured that I could simplify it down, but I really wasn't getting anywhere, so I bailed. And there's nothing that says that just because you picked a side, even if you've spent time on it, that you need to follow through, especially if you feel like you're at a dead end. So we're going to start with the left-hand side, sine to the third of 2x. I notice that on the right side, I do have 1 sine to the first 2x, so I'm going to start over here by factoring. And just go sine 2x times sine squared 2x. So cool, I already have my sine 2x part. I'm going to ignore that for the time being and see what I can do with that sine squared 2x. So I'm going to go ahead and use that power reducing formula and write this as 1 minus cosine of, it's 2 times 2x, all over 2. It's looking promising. I've got the over 2 part, which I can pull out to the front. I get 1/2 sine 2x. And inside the parentheses, I have 1 minus the cosine. 2 times 2x is 4x. And that's it. We're done. Okay. If one side seems to be taking too long, go to the other side, see what kind of luck you have. Okay, notice we're on page 4 of 5 of the notes here. We have got half angle formulas. That's the last little bit in this section. So I've got the sine of a over 2 equals plus or minus the square root of 1 minus cosine a all over 2. Understand that that plus minus does not mean we're going to have 2 answers. It means that we need to assign the sign that goes with the quadrant we're in. Okay, so cosine of a over 2, same thing, equals plus or minus. This time we have the square root of 1 plus cosine a over 2. Tangent of a over 2, notice that we have 3 different versions. We have plus or minus the square root of 1 minus cosine a over 1 plus cosine a. We could also write that as the sine of a over 1 plus the cosine of a, or 1 minus cosine a over sine a. Notice here we don't have those plus minus options. So let's start. Example 7, A. We want the sine of 15. Now this is what takes a little getting used to. 15, let's get that formula in there. I'm going to think of as 30 over 2. So when I go to plug this into my equation, my A is actually that 30 degrees. So 15 degrees, that's in quadrant 1. So I know that my sign would be positive. So I'm not worried about a negative square root. We're going to leave this as positive. 1 minus. And the whole thing went. 1 minus the cosine of 30 over 2. I got the square root of 1 minus the cosine of 30 is square root of 3 over 2, all over 2, and that is not pleasant to look at. I mean, we aren't crazy about the radical under the radical part, and even less so about the fraction in the fraction part. So what I'm going to do here is multiply numerator and denominator by 2, just so we can clear that fraction in our numerator. So I've got the square root now. 2 times 1 is 2, minus square root of 3 over 2 times 2 is square root of 3. 2 times 2 is 4. We can take the square root of that denominator. We end up with the square root of the quantity 2 minus square root of 3, all over 2. And that is our sine of 15. B, cosine of 165. So here's the thing. I could do a cosine sum and do cosine of 45 plus 120. We have values for both of those. We are going to use the half angle formula because 165 is half of 330, so my A is going to be 330. So I have the cosine of 330 over 2 equals. So let's take a look at which quadrant 165 is in. 180 is halfway around, so 165 is in quadrant 2. In quadrant 2, the cosine is negative, so as we deal with the right-hand side here, we know that we're looking for a negative value. So I got 1 plus cosine of 330 all over 2. So I got negative 1 plus the cosine of 330 is square root of 3 over 2. This is all over 2. We're going to do the same thing we did when we were working with the sign. That's multiply the numerator by 2, multiply the denominator by 2, and we get negative square root of 2 plus the square root of 3, all over 4 still under the radical, and that gives us negative square root of 2 plus the square root of 3, all over 2. And that's it. We definitely don't want to leave that 4 in the denominator under the radical. Anytime we have a perfect square that we can pull out, we want to do that. Example 8, find the exact values using the half angle identities. So we know that the tangent of alpha equals negative 4/3. A lies in quadrant 4. So first things first, I'm going to draw my picture. And my tangent is negative 4 over 3. So this is a Pythagorean triple. I know that my hypotenuse is 5. That means the sine of alpha is negative 4/5. The cosine of alpha is 3/5. And the tangent of alpha is negative 4/3, which is what they told us to begin with. So I just tend to write that down so I know that I haven't screwed something up. So we now need sine of alpha over 2. So if we're in quadrant 4, I know that my sine has got to be negative. So we've got a negative square root of 1 minus the cosine of alpha is 3/5. This is all over 2. Negative square root, 1 minus 3/5 is 2/5, all over 2. I get the negative square root of 2 over 10, or the negative square root of 1/5. We could write that as square root of 1 over square root of 5, and then rationalize the denominator. Because square root of 1 is just 1. So I get negative square root of 5 all over 5. Cosine. Quadrant 4, our cosine is positive. I got 1 plus 3/5 all over 2, which is 8/5 all over 2, which is the square root of 8/10, which is the square root of 4/5. I'm going to rationalize that denominator. Square root of 4 is 2. We end up with 2 square roots of 5 over 5. Last one on this page, tangent of alpha over 2. So here's the thing. I've got cosine. Might as well use that. So we are going to go with square root. We're in the fourth quadrant, so the tangent's got to be negative. I have got 1 minus cosine, which is 3/5, over 1 plus the cosine, which is 3/5. Negative square root of 2/5 over 8/5, which is the negative square root of 2/8. Negative square root of 1/4, which becomes negative 1/2. Which makes sense because if we compare cosine and sine, other than the sines, if we ignore the sines, the cosine is 2 times what the sine is. So sine over cosine, 1 over 2. That all makes sense. And let us make sure we can find our answers. And there we go, that's page 4.